Okay, I'm going to go through a book in order to try and work up to regression quickly. I don't know how quickly it will be. So we'll look at what these are chapters 1, 2, 3, 4, 5. Picturing distributions with graphs, describing distributions with numbers, the normal distribution, scatter plots and correlation, regression. Now this normally would take me 14 weeks. I'll try and do it in 1 hour or something like that. First of all, in statistics we use the words individuals and variables. So individuals are the objects described by a set of data. Individuals may be people, but they may also be animals or things. And a variable, so an individual, like if we're talking about wines, the individual might be each wine. If we're talking about a study about grades at a university or something like that, the individual might be the students. And then we have a variable, and a variable is any characteristic of an individual. So if we're talking about wines, a variable could be the alcohol content, it could be the sugar content, it could be the color of the wine, and so forth. So a variable is any characteristic of an individual. In mathematics we would say a variable is actually a function from the individual to maybe the real numbers, if it's a numeric variable. Anyway, a variable is any characteristic of an individual. A variable can take different values for different individuals. So if we're talking about wines, each wine will have a different alcohol content. Each wine might have a different color. So then we talk about variables. We can talk about two types of variables. We say a variable, a categorical variable versus a quantitative variable. So again, if we're talking about wines, a quantitative variable might be the alcohol content or the sugar content or the price. A categorical variable might be the color. So you might have red, rosé, white, or you can have whatever, various other gradations of color. So a categorical variable places an individual into one of several groups or categories. A quantitative variable takes numerical values for each arithmetic operation, such as adding. Anyway, for a quantitative variable, averaging makes sense, whereas for a categorical variable, like color, you don't really talk about the average. Okay. So here's a spreadsheet. Here's part of the data set in which a professor records information about student performance in a course. So you can look at the top row of this data set, of this spreadsheet. We have name, school, major, some kind of total, midterm, final exam total, and grade. So name is a variable about the individual. In this case, the individuals are the students. And name is a characteristic of the students, and it can take on these various values, in other words, their names. School major also is a categorical variable. It can take on educational psychology, for example, psychology, biology, math, and so on. On the other hand, like midterm is a numeric variable. Okay, grade at the end there is a categorical variable. Here's another example. I'll skip that. Let's see, what's this? So categorical variables, pie charts, and bar graphs. So if we have this data here, what is this? The formal name for garbage is municipal solid waste. Here's a breakdown of the materials that made up American municipal solid waste in the year 2000. So the material is the variable, and the values of this variable are food scraps, glass, metals, paper, plastics, and so forth. And we can see here that, for example, food scraps were 11.2% of the municipal waste. Okay. So now we might want to display the distribution of this variable. Right? So we could do that with a pie chart like that. right? So these are the different possible values for the variable called material. And this is also shows the so-called distribution of this variable. You can also display the same thing with a bar graph, and that would look like this one. Okay? So this displays supposedly the same information that the pie chart does. Now, on the other hand, actually there's no reason why I can't switch these around. In other words, switch for example, put food all the way to the right. I'm not changing the height of food, but I can switch it all the way to the right. So I can rearrange it like this. Okay? And there's no reason why I can't do that. On the other hand, if this, now what the variable here was material, if the variable had been a numeric variable, then along the x-axis we put the values of the variable, just like along this x-axis we have the values for material. Along the x-axis we would put the values of the numeric variable, but it wouldn't make sense really to switch the order once you did that, right? You don't take 10 and put it to the right of 100, generally speaking. But with categorical variables, you could do that. Now here, when you have a quantitative variable, we can make what's called a histogram, which looks like a bar graph, but it's slightly different. So let's take a look at that. One of the most striking findings of the 2000 census was the growth of the Hispanic population of the United States. Table 1.1 presents the percent of residents in each of the 50 states who identified themselves in the 2000 census as Spanish, Hispanic, Latino. The individuals in this data set are the 50 states. Let's look at this data set, table 1.2. Where is that? Here. So the individuals we're saying are the states, and with each state we're talking about a variable being the percent of Hispanics in that state. So, okay, so the individuals are the states, and this is and the variable is percent of Hispanic. Okay, so let's see. So what do they do here? They have the data here, table 1.1, and step 2, they count the individuals in each class. So what does that mean? They're going to, so again, the variable is the percent, and what they're going to do is like bin the variable. So they're going to talk about 0 to 4.9%, 5.0 to 9.9%. Right, you can see that here, right? 10.0 to 14.9%. Okay, so they're since the variable is percent, it obviously goes from 0 to 100, and we're going to break that up into bins or classes. So we have 0 to 4.9, 5 to 9.9, and so on. And then we can count how many states were in each of these bins. So apparently 27 states were between 0 and 4.9% Hispanic, and so on. Now once we've done this binning, we can make a histogram. And we get something like this. Okay? So this is the number of states versus the variable, which is percent Hispanic. So you can see that there were 27 that were between 0 and 5, and that's the largest percent, the most frequent percent among all the states. Okay, so this is called a histogram. Now, if we go back and look at that histogram, we can talk about the distribution or the shape of the histogram. And as I said, this bar over here is the tallest, and basically it seems to be decreasing as we move to the right. So we would say that this is not a symmetric distribution. It's kind of, we'd say it's skewed to the right. Okay, I'll stop here and continue.